Alright, I know you're going to like this video because this is puzzle for you guys. This is from the Berkeley math tournament, the mini version because it's for middle school students. We are going to use the information to fill in the boxes, and some of the boxes are going to be blocked, meaning that you don't fill numbers with it. Okay, let me explain the puzzle a little bit. First, we have all this clue here, and then we're going to use them to fill in these boxes. But not all the boxes have to be filled in with numbers. There are some blocks. So let me show you. Right here it says H across, and at the end it says parentheses 4, right? That means we go to H right here, and we go horizontally across, and it's meant to be just a 4-digit number. So we will place a block right here, meaning that this right here is just does not have any number. Then that's called a block. And you should definitely pause the video right now and try this first because this is so much fun. Ready? I'm going to continue solving it. Now, same thing. Next one, we have I across. It also has parentheses 4. So we have this, and then I can place a block right here. And use the same approach. We see the parentheses 2. That's E down. So it's meant to be a 2-digit number. So I will place another block here. We have 3 blocks so far. And then, this is parentheses 5. That's F down, but that doesn't really help because it does have 5 boxes. So does that mean we only have 3 blocks? Well, I don't know yet. Right? There could be more. So we better start reading the information. Let's see. I will start with the easiest number though, because of the 2 right here. I think that's the easiest. That's E down. This number is less than 10. So that means we must have 0 something. And it says the number of blocks in the grid is half of this number. So this is the whole grid. And so far we have 3 blocks. And if we only have 3 blocks, that means this would be a 6. But if we have another block here, then 4 blocks, that means we will have 8 right here. So I don't know though. It's either 6 or 8. Let's see. Let's actually take a look at F down as well. This right here is also kind of tricky and confusing. It says its digits are in strictly ascending order, that means going up, and 4 of these digits do not appear in any other number in the grid. And we have 5 digits. So what that means is that suppose the numbers are just 1, 2, 3, 4, 5, this 5 digits. If I put this down, that means 4 of these right here must not appear in any other number. But which 4? In fact, we know from the first information. It says A across. This is a palindrome. Palindrome means it's just a number that when you read from left to right, it's the same as from right to left. So for example, 1, 2, 5, 2, 1, it's a palindrome, and 0, 0, 0, 8, 0, 0, 0, it's also a palindrome. Alright, so here, if I put down a 1 right here already, that means this right here also has to be a 1. But this right here will violate the 1 showing up in another number, right? So this is not a number that has to be fixed. In fact, based on F down and what we mentioned earlier, we must know that these 4 numbers, these 4 digits here, must be unique. So if I put down 2, 3, 4, 5, that means I shouldn't see any 2, 3, 4, 5 in any other boxes, and also number, meaning that, here's a key. This right here is a 5, yeah? And then J across. If you go from here to here all the way, that means the number J across will also contain the number 5. That violates F down. So in fact, right, this might be the confusing part. In fact, we must have another block here. In fact, J across must be a 4-digit number as well. Okay, that is a lot of work already. And I don't know what these numbers are, so I will just have to cross them out. But now I know we have 4 blocks. That implies E down must be 0, 8, which also implies this box here also has to be 8 because it's a palindrome. So far so good. Now what though? Well, let's see if there's any freebies. In fact, there is. Let's take a look at J across. It says its leading digit is 2. So that means this must be 2, so yay. And now let's face the reality, the hard part. It says this number is the product of B down's digits. Okay, so that means we better take a look at B down right here. So multiply its digits. Okay, let's go ahead and look at B down. B down, it says the following here. The product of this number's digits has exactly 4 distinct prime factors. Whoa. Okay. 8 is the same as 2 to the third power. So we have the prime factor 2 already. And in fact, we're just talking about digits, so they are all less than 10. And in fact, we only have 2, 3, 5, 7. These are the 4 primes less than 10. So we must see this as their prime factors. We have 8, which implies we have 2 to the third power already. And we have 1, 2, 3, 4. 4 more spots. So let me just put it down like this. So what else can it be though? I could have another 2, that's okay. And then maybe even 4, right? Maybe possible. And then 3, 5, 7. Yeah, that's a possibility. But is there any others? Yes, I can start with 8, right? 2 to the third power. And then I could also have, maybe I will repeat the 3, right? Let's say 3 and then 5, 7, and then another 3 or so. But I can also use 1. That's also a possibility. And in fact, let me just put on what I said. I can have 2 3s. So let's say we have 3 times 3 and then 5, 7. And we can also have 2 to the third power times blank, 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 blank. I can even have 9 and then 5, 7, and 1. Because 9 is the same as 3 to the third power, so 1 prime factor, 2, 3, 4, they are all different. 1 doesn't matter. Alright, which one are we talking about though? Well, these two, in fact, you will get the same product because 3 times 3 is 9. So it's tricky. But remember what we mentioned earlier. These 4 numbers, right? These 4 digits, they should only show up in there. And let's keep track of how many digits that we have. So I will put this down right here. In fact, this right here is a no. Because here, we will be using what? This is 8, and then the digits 9, and then 5, 7, 1. So these are 5 digits already, but don't forget we still have this 2 right here, and then this 0 here. So that will give us what? 4, 6, and 3 left to fill in this 4 spots, which is not possible. So not that. All right, so I'm going to get rid of that. That seems pretty nice. Okay, now why not this right here? And maybe this, or maybe that. Well, remember the product of the digits here is equal to j across, and j across start with 2. So let's just go ahead and multiply it and see what happens. 8, 2, 3, 5, and 7. If you work that out, you will get 1680, which does not start with 2. So this right here is out of the consideration. And then similarly, 8 times 3 times 5 times 7 times 1. You will get only 840. So also out. And then if we multiply 8 by 3, 3, 5, and 7, we will end up with 25, 20. Yes, that is correct. So we must have 2, 5, 2, 0 for j across. And in the meantime, we will also know that these numbers here, although I don't know the order, but I must have 3 and 7, 3 and 7, 3 and 7. Another thing I want to mention is that can we have 2 to the third power times 3 times maybe 5 and then another 5 and then 7? Well, this right here gives you 1, 2, 3, 4. 4 distinct prime factors as well. But if you multiply this right here, 8 times 3 times 5 times 5 times 7, you will end up with 4200. So out of the consideration. So it must be this. And you can also check the other possibility. That will be too big. Let me just erase all this right here. Whoa. Okay. Let's see what else do we know. So far so good. And now let's go back to these boxes right here. And let's use the same logic like what we did earlier. Let's keep track of how many digits we have used so far. We have used 0, 8, 2, 5, and then 3 and 7 must happen as well. So 3 and 7. Okay, that means we're left with what? We're left with 1, 4, 6, and 9. And in fact, these are the 4 digits that we must fill in the blue circle right here, right? Well, not circle, but you know what I mean. And the condition of filling in these boxes is that the digits are in strictly ascending order. That means they have to go up. So we must have 1, 4, 6, and 9. Yes. And then you shouldn't see any 1, 4, 6, and 9 in the remaining boxes. How about this number though? What do we do? Well, it has to be ascending order, so that means this right here must be 0. Also, when we put a 0 here, A across ends with 80. That satisfies the condition that A across is a multiple of 40. Good. And because we enter the 0 here, that means A across starts with 0 as well. Wow, I see some progress. That is very, very satisfying. Okay, now 3737. I don't know yet. Let's go ahead and just take a look at other information. Now let's go ahead and take a look at G across. This is an odd number, and the digits are in strictly descending order, so we cannot end up with 1 because the 1 is right here already. So can we end with 3? Yes. And how about can we end with 5? Well, if we end with 5, that means this right here be 6, 7, and 8. But this right here is 6, which repeats, so no good. And similarly, if you end with 7, that doesn't work either. So in fact, G across must end with 3. And for this number here, we cannot put 4 because 4 is right there already. And can we put 5? I think so. Let's put it down for now. We cannot put 6. If we put 7, then that means it will be 8 and 9. Again, that violates, so cannot put 7. So that means this right here must be 5. And then this right here must be what then? It must be 7. Because remember, G across has to be descending order. So in fact, I can erase the 3 and 7. I will just put down a legitimate 7 right now. And then it will start with 8. Descending order. Again, you cannot have 9 because 9 is right here already. Wow, I didn't know F down is that useful. So that's G across. And now, here is the deal. Remember what we said earlier? B down, it must be 8, 7, 3, 3, 5 now. Because when you multiply them, you end up with 25, 20. So in fact, we can also, decided that these two boxes must be both 3's. Okay, we're making a tremendous amount of progress. Okay, now let's see. Let's see A down. Is there anything that we can say about A down? Okay, A down says this number has only even digits. Okay, so we have 0, 8. We cannot use 4. We cannot use 6. So that means either 0, 8 or maybe 0, 2 and all that. I have no idea, so that is not that useful. Now, let's see. Perhaps let's figure out C down. Okay, C down and D down, they sound like extremely confusing. Let's read C down first. C down says each digit of this number is 2 more than some digit of D down. Meanwhile, D down says each digit of this number is 2 less than some digit of C down. Whew. What exactly do they mean by that? Well, let me explain. So as you can see, D down right here, right? 3 is 2 less than 5. Good. And also 0 is 2 less than 2. Good. But here's the thing. They don't have to be right next to each other. That's the reason they say some digit of D down. So for example, I could have, let's say, 7 here, and then in that case, I must have a 5 here. Then you see 5 is 2 less than 7. So just keep that in mind. Okay, that is still pretty hard. So now let's think about what we can put right here. We cannot use 1. Can we put down 2? If we put down 2, that means somewhere here we must have 4, because we must have some like 4, so that is 2 more than 2, right? But 4 is forbidden because of this right here, so we cannot put down 2. Can we put down 3? Well, if we put down 3, then that means we must have 5, so it seems legit, right? But when you put down 3 right here, because A across is a palindrome, that means we must have a 3 right here, which also implies we must have a 1 somewhere down here. Oh, wow, that took me a while to actually think about that. So 3 is not allowed. Can we have 4? 4, no, it's right here, so no 4. Can we have 5? Maybe, so 5. So just keep that in mind. We cannot have 6, so get rid of that. Can we have 7? If we put on 7, that means we must have some 9 here, right? So no 7 either. Can we have 8? Well, that means we must have 10, which again does not make sense. So in fact, this right here must be equal to 5. Whoa, okay. And because that's equal to 5, that means this right here is also equal to 5. Okay. Now, almost done. We really have to look at H across and also I across. So H across says this number has exactly 2 distinct digits. Okay, that doesn't really do anything because I could have like 2, 3, 2, 3, or maybe I don't know. Let's take a look at I across. I across says this number starts and ends with the same digit. Okay, thanks, but I still not so sure. So now why don't we take a look at A down? This number only has even digits. So we have 0, 8, 2 right now. And remember, we cannot use 4 and 6. So that means we can only have like 0, 8, and 2, 0, 8, and 2. And now let's take a look at this box right here. Which one does this have to be? I will tell you, it must be equal to what? 0. Why? Let me actually write this down right here first. This right here has to be 0 so that I across, right, this digit will be the same because it says so right here. It starts and ends with the same number. Imagine earlier I put down a 2. That means this right here will be a 2. And that will imply we must have a 4 somewhere in the C down number. So cannot be 2. And it cannot be 8 because if we have 8, then that means we have to have a 10 somewhere. That doesn't make sense either. So it must be equal to 0. Now check this out. We have 5 in D down right here. That means right here, we better have a 7. So it's either here or here. But it cannot be here, because suppose the 7 is here. Remember, H across, this right here has exactly 2 digits. So both 3 and 7 are odd. This right here will contradict with A down. A down says this number has only even digits. So you cannot fill in this right here. So you cannot have a 7 right over there. That means we must have a 7 here. So now, what should we fill in right here? Can we fill in this with 8? The answer is no. Because if I put down the 8 right there, that means either this right here is 8 or that right here is 8. But again, that will contradict with the 2 more, 2 less than, right? So not that. Can I put a 0 here? Well, no. Because if we have 0, 3 in H across, that means either we have 0, 3, but this right here, remember, 0 is not 2 more than any of these numbers here, so it's not possible. And if I put down 3 here, that means we must have a 1 somewhere here, but I don't have 1, so we cannot have 0 there. And 4 and 6 we cannot use, so that means we must have a 2 there. And then what else do we know? So 2, 3, right? So we just need to fill in the last 2 boxes. And now, can I put a 2 here? Well, the answer is no, because if I put a 2, that means I have to put a 4 here, so that contradicts. So that means I better have just a 3 right here. And finally, what's this number? Is it 2 or 3? Well, it cannot be equal to 3, because if I put a 3 here, then I must have a 1 somewhere here, right? So I cannot do that. That implies this right here is a 2. Oh my goodness. I'm all done. And I think this right here is correct. Now everything makes sense, right? If you follow everything, let's go ahead and just check. I will use highlighter for you guys as well. First, the A across. We have a palindrome, and that's a multiple of 4. So 0, 8, 5, 5, 8, 0. That's a palindrome. And then multiple of 4 because 80. Good. So the first one checks. Now, G across. This is in strictly descending order. G across. So going down, right? 8, 7, 5, 3. And then because the last digit right here is 3, so it's an odd number. Good. Now, H across. This number has exactly 2 distinct digits. So we're talking about just 2 and 3. Good. And then I across. This number starts and ends with the same digit. So we have 0 and 0. Good. And then J across. This number is the product of B down's digits. And the leading number is 2. So if you multiply 8, 7, 3, 3, and 5, you do get 2, 5, 2, 0. So good. A down, this number only has even digits. 0, 8, 2, 0, 2, they are all even. Good. And then B down, the product of this number, we did that earlier. So this is, prime factor is 2, and then 7, and then 3, right? And then 3. Double counting is okay. And then 5. So 2, 3, 5, 7. Good. And then C down. Each digit. Oh, yeah. Okay. Let's verify this one because it's tricky. I see 5. 5 is 2 more than 3. I see 5. 5 is 2 more than 3. Good. I see 2. 2 is 2 more than 0. I see 7. 7 is 2 more than 5. I see 2. 2 is 2 more than 0. And in fact, D down and C down, they are pretty much telling the same thing, but just to be more precise in my opinion. Good. Now, E down, easy, right? 0, 8, because we have 4 blocks. Yes. Finally, F down. Yes, 0 and then 1, 4, 6, 9, and then 1, 4, 6, 9. It's not including any other numbers, right? You see, J across does not have the 9. Yes, we are done.